Alrighty, hello, it is Mr. Biggers, and today we're going to be learning about some more exponent laws. Our essential question today is, what are exponent laws, and how does it affect the way we do math? So if you're watching my video and you aren't one of my students, this may be one of the first laws you're learning about, but for my students, this is, we've already learned about several laws already. So essentially, we're going to start out with our main question right here. What is the power of a power law? Obviously, I highlighted power of a power. That means it's probably important. So what does a power of a power mean? Well, before we even read the purple paragraph here, I want to go ahead and zoom in here. See how I have a number, this 5 to the third power, right? It's also then raised to another power. So I have a power to a power. So that's kind of what that means when we're saying power to power law. So what I want you to do here is follow along with me as I read this, and then I want you to pause the video and get it copied down because I'm going to move faster in the video than you're going to be able to write. So, if an expression of a base raised to a power is then raised to a power again, you just multiply the exponents together. Okay, so pause the video, get that copied down. Now that you got that copied down, we are going to go ahead and move forward with our example 1. So I'm going to zoom in here so we can see it a little better, and I do want you to write this down. So I have a power raised to a power, and our rule essentially says that we just multiply those two powers together. Keep the base the same. So if we multiply the powers, I have 5 to the 3 times 3 power. What's 3 times 3? That's easily just 9. So my final answer would be 5 to the power of 9. Okay? But now we're going to talk about, why does this work? Why does this work? So I want you to copy that down again. Why does this work? Okay, well, I have 5 to the third power, and we know that can be written as, so I'm going to rewrite down here, 5 to the third to the third. So I'm looking at the inside of my parentheses here, and I know 5 to the third power can be written as 5 times 5 times 5, right? Now, don't forget, I have that whole thing to the third power again. So that can then be written, so if let's switch to an orange here. So if I'm looking at these parentheses, I have 3 of these guys multiplied by each other. You see that? Because it's raised to the third power. So then I'm going to have 5 times 5 times 5 times itself 3 times. And I want you to go ahead and copy this down because I need you to see why and how this works. So now you can simply, now that we've expanded our exponents, you can simply count how many 5s you have. And how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 5s, which means that I could then rewrite this as 5 to the 9th power, since I have 5 multiplied by itself 9 times. Does that make sense? I hope it does. So what we're going to do here is we are actually going to do a few more examples, and I want you to get this copied down as well. So for example 2, we're going to have a fraction. So I'm going to have 1/2, and we're going to raise 1/2 to the negative second power, and then I'm going to have that to the power of 3. Well, it's kind of hard to write out a negative power. So we're just not going to worry about it. And instead, we're going to worry about our rule. The power of a power rule says that if I have a power, so in this case, I have a power of -2, and then I'm taking the entire shebang here to the power of 3, all I have to do is multiply those two exponents together. A power to a power means that you need to multiply the exponents together. So my base, it's going to stay exactly the same. My 1/2 just moves over, and then I have a -2 times a positive 3. So 2 times 3 is 6, and then I have a negative. So my final answer is going to be 1/2 to the negative 6th power. Simple enough, right? Let's do another. So this is example 3 over here. And you can go ahead and draw a line to separate those if you need to. We're going to do a decimal this time. So let's have negative 1.3 to the 5th power. And then we're going to have this to the 10th power on the outside. So remember the exponent rules here. We are just, and I'm going to switch to green. We are just going to multiply the exponents because I have a power raised to another power. So 5 times 10 is going to be what? What is 5 times 10? It's 50. So I'm keeping my base the same. If my initial expression is in parentheses, my answer probably also needs to be in parentheses. So 5 times 10, 50. That is my answer. It's that simple. So if you remember these simple rules, you'll be really successful on your assignment. And in my class, example 4 is actually one of your homework problems on this assignment. So if you pay attention to this, you might actually figure out an answer. So I'm going to go ahead and write down this problem here. I have a negative 4 to the negative 5th power. And then I have that raised to the negative 4th power. See how I put that whole thing in parentheses? These blue parentheses here tell me that the entire expression, this whole thing, is raised to the negative 4th power. So all you need to do is what? You just multiply your exponents. So I have a negative 5 times a negative 4. Remember, the base, what I'm circling here, the base is going to stay the same. So copy that down. Keep your parentheses, and then you do negative 5 times negative 4. So negative 5 times negative 4 is equal to what? That's going to be a positive 20 because I have a negative times a negative. So your answer for that problem is going to be this here. So I hope you understand a little bit more about taking a power to a power, and just remember the fact that when you take a power to a power, all you're doing is multiplying the exponents. Matter of fact, I want you to go ahead and highlight that up here. Multiply the exponents. So if you have any questions, please send me a message on Canvas, my students. Otherwise, make sure you get these notes copied down, and have a good day and good luck on your assignment.